Hello everyone, welcome to Missile8964 Hardware Reference Design. It is a new paradigm shift in industrial design which allows electronic and computing devices and smartphones to be manufactured in every nation on Earth by December 1st, 2021. Let's begin. This project will be made public domain for every nation and every person on Earth. It is a combination of three concepts. First, open connection architecture. We will come back to this term at the end of this presentation as it will make everything clearer after seeing the whole thing. The second is a 3D printing and public domain file library. And the third concept this involves is called the externalized batteries. What's required for every nation to gain this capability to manufacture computers, smartphones, and electronics locally is actually surprisingly simple. First, each nation needs to build a PCB fabrication factory or buy PCB boards from trusted neighbors. Now, PCB boards can be quite complicated or quite simple. However, making PCB boards is not as complex as it seems. There are videos on YouTube that teaches how to make PCB boards by hand, manually. The second thing every nation needs is one SMT machine. SMT stands for surface mount technology. This machine will put electronic components onto a PCB board. And what's required for Missile8964 is a surface mount machine that can handle PCB boards the size of a credit card. The third thing we need are 3D printers or CNC machines at various desired locations. With the price of 3D printers coming down, it is actually quite easy to gain access to a 3D printer. It is actually possible to build your own 3D printer from tutorials that's available on YouTube. Let's begin with the most basic component of Missile8964 design. It is called a cockerel. Basically, it's a single board computer that's the same size as a credit card and the height restricted to 0.6 centimeters. The rest of the technical specifications are one single ARM or RISC-V 64-bit CPU, minimum 8 gigabytes of RAM, 2 micro SD slots, 1 camera and 2 microphones, 3 USB-C and 1 Thunderbolt connectors. For wireless connectivity, it would have 5G cellular, Bluetooth 5.2, and 11AX Wi-Fi connection capability. Next, we have the power sources. Again, they are restricted to credit card size times 0.6 centimeters in height. Let's begin with the battery. With a dimension like this, if it is made of lithium ion, it can potentially hold 6,250 milliamps. Next, it is the solar panel board. It will be the same size, but with 4 USB-C connectors. Again, it is restricted to the same physical dimension. Both the battery and the solar panel board would come with a switch that would allow multiple batteries or multiple solar panel boards, or a mix of both, to be connected in series or in parallel. Next, we have the main container, and this is where the fun begins. The main container is 30 by 21 centimeters. The height of it is roughly 0.8 centimeter. The red rectangle on top is where a cockerel resides. It is enclosed in a 10 by 7 centimeter enclosure. Now, this enclosure is not solid. It comes in a mesh form like what you see on screen. This design would allow a cockerel to be fixed in place and also have thermal capabilities. With a single main container, we can potentially have one cockerel that is powered with 8 batteries. Potentially, this would give us 50,000 milliamps. Next, we have the touch screen. What's defined here is 29 by 19.33 centimeters. This would give us a 13.72 inch touch screen at 3 by 2 ratio. On the 4 corners, we have the speaker boards. And in the center on top, we have 1 camera and 2 microphones. At the bottom is a space for an USI pen. Now, the resolution of the panel, as long as it is better than Retina, then we're golden. With what we have just described so far, we have the technical specification of a tablet computer. Now, with this basic design, when we have 8 batteries, we can potentially have 50,000 milliamp power source. However, because this basic container can be externalized, so what happens here is that on top of this configuration you see on screen, it is possible to add another main container which contains only batteries. So that would give it another 9. And that's another drop 56,250 milliamp. Potentially, you can also swap some cases with solar panels. So while you're on the road, this would almost give you unlimited power. Next, we will give our tablet computer some input devices to make it a notebook. What you see here is the input device container. The overall size is the same, 30 by 21 centimeters, and the height will be about 0.8 centimeters. On top, you will see 6 slots for PCB boards. You will see that a basic keyboard is divided into 6 credit card size PCB boards. The 3 on top are standard for any keyboard configuration. However, there are 2 types of main keyboard configurations out there in the world. One is the US and one is the UK. At the bottom, we have another 3 that can be substituted depending on which keyboard configuration you desire. Now, this design would also make the keyboard last much longer because you can replace each board individually if one of them is damaged somehow by water or by repeated use. So if the keyboard malfunctions, all you need to do is swap out the part that is broken. In the past, we might have to replace the whole keyboard. Now we just replace 1/6 of it. At the bottom, we have 3 spaces for other types of input devices. Here is an example of the US keyboard. And here is an example of the UK configuration keyboard. As you can see here, the only difference between a UK and a US keyboard configuration are where the bottom 3 keyboard boards are. Next, we have the other input devices and what is called multiple dexterity. The example we have here, on the right, we can insert a numeric keyboard that is either landscape orientation, which we can leave in place, or if the user prefers, he or she can put in there a numeric keyboard that is of the portrait orientation and just take it out of the slot when he or she needs to use it. In the center, we can have the usual touchpad or a gamepad or a folding mouse or a maker board if we choose. And on the left, because the container space is the same specification, so again, we can have the options of putting a touchpad or a gamepad or folding mouse or maker board here. In this example, the user can choose to have the numeric keyboard on the left if the user prefers. And finally, in this scenario, the user can choose to have the numeric keyboard right in the center. Next, we have the generic kickstand. Now, the overall dimension is still the same, 30 by 21 centimeters. However, in this case, it can be as thin as the material allows, because this gets to be attached externally to either the screen or the input device case. The four configurations are: at the top, we have the keyboard kickstand. When this is attached to the input device casing, the keyboard kickstand will allow it to rise the keyboard portion, or should we say the input devices section, to a more ergonomic position. The other three configurations are for the screen, so this can allow the screen to be positioned in landscape or in portrait position. This generic kickstand is designed like this, so the user can choose to carry as many of these kickstands as he or she needs. Next, we'll talk about the thermal. Now, a Kokoro, by definition, doesn't need this. However, just in case the user for some reason needs it, or if the configuration is more taxing than it is originally intended, it is possible to attach a cooling fan in the center of a main container. And because the frame that holds the boards in place are made of mesh, air will flow freely in the main container case. So let's get back to what we talked about in the beginning of this video, the open connection architecture. Now, if the user follows OCA, the casings can be made from a 3D printer or a CNC machine with whatever material the user prefers. And as long as the user adheres to the OCA standard, they can beef it up to make it military grade with anti-drop and anti-sand, dust, water capabilities. And these casings will become interchangeable. And that is the intention of open connection architecture. Now, if the user never leaves home, like most of us are in quarantine, the material for the casing can be more relaxed because we don't need the structural integrity and the structural strength we need when we take it out there everywhere. As far as the design aesthetics goes, the user can choose to either expose the material and their natural patterns, or paint the casing, or put stickers on the casing. Now, this actually allows far more flexibility in terms of aesthetic designs. If the user prefers a traditional notebook form factor, it can be achieved in two ways. The first one is external hinge, like the one you see here on screen. This is deceptively simple, just like door hinges. And because the design comes with kickstands, the hinge doesn't have to be very strong or be able to withstand thousands of repeated uses, because all it does is just holding the two casings together, and they are as cheap as the door hinges that we use at home, or maybe even cheaper. The other method to make the notebook form factor would be to use external casings. Now, this is even more fun because these external casings can be made of leather, fabrics, neoprenes, and they can be as beautiful as the user chooses to make them. When it comes to the PCB boards, here is a list of all the possibilities. Number one, we can have the Kokoro board. Number two, we can have the Robin board, which we will introduce in the next slide. And then we can have the expansion boards. These expansion boards can be either external storage made of SSDs, or a cooling fan, or they can be expansion boards with all kinds of makers connectors on them, or they can be the Pico boards, or they can be the input devices that we talked about previously. Any company who wants to use this design commercially can design their own secret boards with secret functions. For example, single lens cameras or cinema video cameras. If you would look at the middle right, this board can be divided into multiple pieces when we use it. Here you see 8 speaker boards, 1 PCB board for the folding mouse, and 1 PCB board for the USI pen. When configured like this, it can go through the SMT machine one single pass. And at the bottom right, you see this board for Wi-Fi 6. This should be optional because if you have a Kokoro board, you would be able to have 5G connectivity that you can share as a base station. Next, if you look at the top left, here is a list of all the screen sizes that's defined by Missile8964. The first one is the 13-inch touch panel for the tablet and the notebook computer. The second one is an e-paper version of this, of the same size. Number 3 is an 8x16 screen for smartphones. And finally, we have a credit card size mini touch screen for generic uses. Next, we'll talk about the Robin board. It's very similar to a Kokoro board, except that the technical specification is a little bit different. The biggest difference is that the RAM requirement is a little bit less at 4 GB, and it only contains 1 micro SD slot, and it does not have 5G connectivity. We will show example of how this can be used in the later part of the video, and it will make everything clear. Next, the cooling fan. Again, it is the same size, the same credit card size, and the same height, 0.6 centimeters. And here we have a much easier to read list of the possibilities of these expansion boards, as long as they follow the 8.5 by 5.5 centimeter dimension specification. On top of what we talked about previously, someday we might even be able to fit a mini projector in this casing. Here we have an example of what can happen if you let your imagination run wild. Potentially, you can have a setup that has 1 Kokoro, 2 external GPU boards, and 1 SSD storage expansion board with a cooling fan in the center and 4 batteries. Next, we'll go back to the specifications for the 4 screens. Again, the basic setup is a 13.72-inch touch panel. Next, we can have an e-paper, color e-paper version of this, of the same size. What's interesting is that we can have 2 other screen dimensions that will completely open up Missile8964 and make it a general use design. The first one we have is 8 by 16 cm dimension for smartphones. And the next one is an 8 by 5 mini touch screen. All 4 of these screen sizes can share the same controller board design of the same dimension. Here we have the basic design of a smartphone. The screen is 8 by 16, and on the next layer on top will be a Kokoro. And the rest, the user can either choose to have 2 batteries or, if needed, add another layer of 3 batteries or mix some of them with solar panels. And at the bottom, we have the kickstand that can be attached externally. Next, we can have the mini phone configuration. It would take one 8x5 touch screen, one Kokoro, and 2 batteries. So when we stack them together, the physical dimension of this mini phone would be 8.5 times 5.5 times 2.4 centimeters. And depending on what the user prefers, he or she can attach as many batteries as the user desires. Next, we have a configuration for complex electronics. What you see here again is a basic setup. It contains a 3.71-inch mini touch screen and a rubber board, and as many batteries as the designer of the complex electronic prefers. On top of this, it is also possible to insert a specialty PCB board somewhere in between for secret or specialized functionalities or sensors. This setup can be inserted into other complex electronics such as single lens cameras or video cinema cameras. Next, we have the remote sensor setup for remote or scientific scenarios. Basically, it is exactly the same setup as the previous setup for complex electronics, except in this case, after everything is set up, we can remove the touchscreen panel and leave the rest somewhere we want. Again, on top of what you see here, the designer can also choose to insert specialty boards. And here we have a list of possibilities and advantages of Missile8964 design. On the left, you see a list of what this design can do. Basically, the possibilities are endless. It is even possible to make a supercomputer of any configuration the user desires, and it is portable. And the power source can be unlimited. Imagine a supercomputer you can take anywhere, and you can configure it to be any configuration you like on the fly if you have all the components in storage. And next, we'll talk about the advantages of Missile8964. Number one, every country make their own technology items to grow their own economy and keep the technology jobs in the country. This design would be ready for global deployment by December 1st, 2021. And this is the world's first realistic shot at making global OLPC possible. OLPC is one laptop per child, and this is one initiative started by MIT and quantum computers in the past. Finally, we have a realistic shot at making it happen right away. Next, nothing is made in China. With Missile8964, we no longer need an army of assembly workers to assemble electronics. And this will bring equilibrium in terms of finances, economies, technological powers, and redistribute them back to where they belong, to every single nation in the world. The design is so simple that a high school kid can be trained to do this in a single class. Environmentally, we no longer have to waste material on packaging because from now on, all we have to do is ship certain components internationally. And once they arrive and made into PCB boards in every nation, all we are shipping are credit card size PCB boards stacked together. And they only need minimal protection material. Next, we no longer throw away whole units of electronics. With this setup, if a user decides to retire his or her unit, the functional parts can be salvaged and passed on to the next user. So we no longer even have to do recycling. Well, we can reduce our efforts on recycling, which is basically a ridiculous concept. For a better environment, we respank our products will make more sense. What we mean by respanking is to use functional components from other retired or retiring units and reassemble and mix them with brand new components to make a respanked unit. And this is where the enlightened industrial revolution begins. Another added advantage is that this setup would allow cloud computing and cloud storage to disappear, because all it does is analyze and steal our data without our knowing it. This design would allow the user to instantly unplug data storage to keep the data safe and removed from the network at an instant. And with this setup, we no longer need for really fast network infrastructure just to move data between devices and cloud storage. And that really is unnecessary. With the cheap price of local storage. And best of all, content creators owns and keep all the contents all the way through without putting them in the hands of centralized middlemen distributors like YouTube and iTunes. Now let's go back to our initial mentioning of open connection architecture. Basically what we have would be 3D files that define the position of the screws in 3D. and also the external dimensions of the casings. In this video, we see what this can do for notebooks, smartphones, and tablets, and all kinds of electronics. It is even possible to adapt this to automobiles. Next, let's talk about the logistics. As long as we buy our components from trustworthy sources and countries, we can make our own PCB boards. Every nation can make their own PCB boards within their country and mail or ship them domestically. And because the casing and other components are made in 3D print shops locally, you can just pick them up just like you would do to a local photocopy shop. You can either assemble this yourself because it's really simple, or hire the kid that mow your lawn to do it for you. Or even better, we can have a workshop class in schools to teach students how to assemble these computers and smartphones on their own. And they can go back home and teach everyone else how to do it in their neighborhood. Here we have a list of trusted sources. For example, for the SMT machines, United States, Germany, Japan, Great Britain, Israel, South Korea, Taiwan, Singapore all make them. For the electronic components in the CPU, Taiwan, South Korea, Japan, and USA all have the capabilities to make them. And if they don't make them for some of the components, it will be very fast for these countries to ramp up production within 3 months, before December 1st. And as far as raw materials for your 3D printer goes, use whatever that you have in your country locally. If your country produces aluminum, use aluminum. If you make gold, use gold if it's cheaper for you. If you're good at making ceramics, use it. If what you got is wood or bamboos, potentially you can use them too. And there you have it, Missile8964, a public domain hardware reference design, and a gift from Raconteuria. Missile 8964 is brought to you by Raconteuria, a FOQNE similar to what Neil Stephenson defined in his book Snow Crash. There are multiple open source projects coming up on GitHub. They will be announced one by one starting today, June 6th, 2022. Since last September, I've managed to add the following extras so that the designs can be more flexible and more aesthetic. I am James C. Ling, the author of Solid-Lock, Blueprint for the Technological Singularity, and Claritism, Remove Humanity to Rebuild It and Repair Earth. Here is a list of what I do on the global stage and what I do in Taiwan, business-wise. and how to contact me. Goodbye.